would like to explain about shape of the orbital and with the definition also. So before that, do subscribe my channel and to see more updating videos. Okay, today our topic is shape of the orbitals and definition of orbitals means, and what is the differences between orbital and orbit. Okay, so today's section I hope I will explain with a simple method and with their shapes and orientations and how they are placed on depending upon orbital. Okay, now definition of orbital. Okay, so we know already. So first we draw the center of nucleus. This is the nucleus. We take for example an atom. So this is the atom. This is the nucleus. Center place is the nucleus. So atom has some shells and subshells and their energy levels and some series also we can see here. So this is the atom. This is the central atom. Sorry, this is the atom. It contains, it based on positive charge or this is the nucleus. This is the nucleus, and here some shells are there. That may be K shell and M shell, L, K, L, M, N. Okay, this is a K, L, M, and N. Okay, here some main levels are main energy levels here. Here N is equal to 1. Here N is equal to 2, and here N is equal to 3. And another shell we have is the N shell. N is equal to 4. Okay, depending upon this we can identify the sub levels, means energy levels, and sub shells also. So main shell we have this is a atom. Okay, this is a circular shape. The circular shape we calling as shell. So the electrons present in the shell we calling as valency electron. Okay, or valency shell. So within the valency shell the electrons is lies we calling as electron, means valency electron. Before that we identify the orbital, means definition of orbital. Orbital means that orbital is a place the probability of finding electron is maximum, or it may be it is a circular shape, the atom. So it covers shell. So orbital means it may be an atom or molecule. It may be 0 or 2 and more than that. So that we close means that that electrons are revolves around this shell or this around the nucleus. Okay, that we calling as orbital. This is another definition. Okay, and when we compare to orbits, main huge difference is orbits and orbitals is different way. Okay, so orbit means that orbit is a circular path and orbital is a space. The space it is lies in space, but orbital is lies in circular manner. So revolving electrons around the nucleus, circular is fixed path. The fixed path we calling as orbit. Okay, so can you guess this differences orbit and orbital? So I think we are guessing now. So orbit and orbital. Next here some these are N. N means number of electrons or main shell. Okay, N is equal to 1, N is equal to 2, N is equal to 3 depending upon their energy levels. And here some K, L, M, N. This is a sub levels. These are the subshells. Within the subshells here we calling as S, P, D, F. Okay, the S, P, D, F, these orbitals are derived from the some alcoholic electron or spectroscopic lines. Okay, spectroscopic lines. It is derived from the spectroscopic lines that we named as S means short, and P means is a principal, and D diffuse, F means fundamental. These are the basic concepts of an atomic structure. Okay, now we will see in case of s orbital here. Okay, now we see shape of the orbitals and what are the how many electrons are present in the orbitals and how many electrons are there in the shell. Okay, next S and P D F. These are orbitals. 4 orbitals we have. 4 types of orbitals are we are seeing today. So S orbital. S orbital have 1 S. P orbital is 1s and 2s, and here S 2s and 2p, and here 3s and 3p 3d. Okay, here 4s and 4p and 4d. Okay, this is a basic concept of in atomic structure about the process of SPDF orbital. Okay, S orbital have 1s and 2s and 2s and 2p. Here P orbital. P orbital contains 2 orbitals. Here 2, here 3, here 4 orbitals are present in the F shell. Okay, and next before that, in S shell, in S orbital we have only 2 electrons. In P orbitals we have 3 pairs is equal to, already yesterday in the next class, in previous class already I told you, in 3 pairs equal to 6 electrons present in the P orbital, and D orbital is 5 pairs is equal to 10 electrons, and F orbital, in the case F orbital we have 7 pairs is equal to 14 electrons. Okay, here SPDF, here SPDF, can you guess now? 4s and 4p. So what is 4 and what is S? Means 4 is a number, n is equal to, means it is a energy level. Okay, I told you now, it is a energy level. S means it is subshell. Okay, energy levels means 4, n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4. The number is 4. That is the energy level or main level. Within the main level we have subshell, that is the S. We named as S orbital and P orbital, D orbital. Okay, these are 4 orbitals are present in the F, and 3 orbitals present in the D, and 2 orbitals, here 2 orbitals S and P contains. Okay, can you understanding this? Okay, I think we are understanding well, I think. So we will discuss now shape of the orbital. Okay, now we can discuss the shape of the orbital. Shape of the S orbital. Okay, in the shortcut form I will write right now. Okay, next shape of the S orbital. Here shape of the S orbital shape is a spherical shape. I can draw now. This is a S orbital, means we have spherical shape. It is unidirectional, and the electrons are go and or move forward in same and with all in all directions. Okay, here Z, here Y and X. So it is arranged in symmetrical manner, and when we cut to this orbital section, it divided as two identical. So it is to be identical. Okay, this is a S orbital structure, and here the value of L is equal to 0. Okay, according to quantum numbers, principal and azimuthal and magnetic and spin quantum number. So value is L is equal to 0, M is equal to also 0. Okay, this is the shape of the S orbital, and the structure also we seen here. Okay, and next symmetrically it will be arranged. Okay, it is the probability finding electron is a maximum or a maximum here. Okay, next P orbital, shape of the P orbital. Okay, shape of the P orbital here. Next we write here like this also. It is arranged in 2 lobes. Means 2 lobes here. It is Y, Z, X. That means we have 3 types here. In P orbital we have 3 types: Px and Py and Pz. Okay, Pz. So we can talk just P orbitals, about P orbitals. That's why we're calling as Px and Py and Pz, right? So next means we have 2 lobes. Here positive charge, here negative charge. So the electrons is moving this direction only, this plane. it will be symmetrically arranged. And about px and py orbitals here, this is likewise, this is px orbital, and this is py, and this is a pz. This is a pz, okay, this is a pz, this is a pz orbital, right? So these three are identical and equal energy, okay. Orientation also same. When we are talking about f orbital, means f orbital, it will be different, but same, it will be complicated structure also. So now we see p orbital is completed, and it is p orbital is symmetrically arranged, and it is when we cut to the p orbital, it will be become as a different, means same structure, or it will be identical. So now we talking about d orbital, shape of the d orbital, okay. So d orbital, we have five orbitals. So 5 shape of the orbitals means 5 structures we have, means d contains 10 electrons, 5 is equal to 10 electrons, okay. So now we write the structure, means dxy and dyz and dzx, and dx square minus y square and dz square, okay. Now we draw the structure of this 5. This means here same orbital, the orbitals is located between the plane, this is a p, means a d xy, and this is also same d y z, and next this is also same d zx. Next this will be next, this is different, it will be present on the axis, this axis, okay. This is dx square minus y square. Next, when we come to the dz square, it will be different, okay, it will be different. This is x, this is a z axis, so here this is dz square, okay. This is structure of dz square, means it will be all the structures are similar and identical, but energy will be same. When we come to f orbital, okay, f orbital, shape of the f orbital is complicated, means structure is complicated when we drawn here, so I didn't drawn here, sorry for this. So I will explain with their description, okay. S orbital, now we see f orbital, now we see f orbital, shape of f orbital here. So it is a complicated structure when we draw on the board, or when we draw on page or paper. So the structure of f orbital means when we drawn in mathematical expression, so x into x square minus y square f, and in the place of z, in the place of x we put z, and in the place of z we put y, as usual same but different in x y z, and x y z and z cube, okay. This is the structure of means this is a mathematical expression of f orbital. So f orbital is it is a very more complex material, and it has 14 electrons, 7 pairs,